Okay, so last time we looked at all of the complex derivatives with ln's and e's, okay? So today what we're looking at is a couple of different applications, well really just one application, but then one other way to differentiate, okay? So if you remember, we had the tangent line problem, okay? So that's where I asked you to find the slope of a tangent line and then write the equation in slope-intercept form. Not slope-intercept form, point-slope form. Okay? So let's see, just remember how to do a basic one. All right, so if I want to find the tangent line of the function that goes through the given point, the first thing that I'm going to do is take a derivative. Actually, the first thing I'm going to do is choose a pen. Now I'm going to take a derivative. Great. This is fantastic. Okay. So f prime of x is 2x minus 2. All right. So there's my derivative. So if I want to find the slope of a tangent line, I need a derivative, and then I've got to plug in my x value of 2. Okay. So f prime of 2 is 2 times 2 minus 2, which is 4 minus 2, which is 2. Okay, so that is the slope of our tangent line. 2 is the slope of our tangent line. So this is m tangent. That doesn't say ton, it says tan. Okay, so there's the slope of our tangent line. So then all we had to do was say y minus y1, so y minus 3 equals m times x minus x1. There's our answer. Okay, so that's all we're doing today. We're just doing it with natural logs and exponentials. Okay, if you need a summary of the process, there it is. Okay, we're going to take a derivative, plug in the x value to get the slope. Okay, and then we're going to put that in point-slope form. So if I want to find the tangent line of the function that goes through the given point with this e1, okay, so the first thing I'm going to need to do is take a derivative. So maybe f prime of x, so you would do the derivative, so you're going to write it down. That's a 2, or it's at least supposed to be. Times the derivative of whatever you just wrote down. So it's times 6x minus 4. Okay. So then if I want to plug in my value to get my slope, so f prime of 1 is going to be e to the third minus 4 plus 1 times 6 times 1 minus 4. All right, so that's going to be e to the 0 times 2. All right, well, if you remember, anything to the 0 power is 1. So our slope is 2. So then all we have to say is y minus y1 equals m times x minus x1. Okay, so let's look back at that. We took a derivative, which to take a derivative of e, you've got to write down the problem and then multiply by the derivative of the exponent. Then we plugged in our x value of 1 and got that the slope was 2 and put that in point slope form. Okay, let's look at it with an ln. So if I want to take this derivative, f prime of x, I'm going to put whatever's on the inside on bottom, take the derivative of it and put it on top. So the derivative would be what? 8x cubed minus 2x. Okay. So now I've got to plug in the x value, so f prime of 0 is going to be 8 times 0 cubed minus 2 times 0 over, okay, 0 minus 0 plus 3. So we get 0 over 3, which is in fact 0. So the slope is 0. So we're going to have y minus y1, which is the ln of 3, equals 0 times x minus 0. And yes, that is not the simplest that it could possibly be, but remember, we don't really care. We got the equation of a line, we did what they told us to do, we move on, okay? All right, let's look at one that's slightly more complicated. So if I want to take this derivative, there's a product rule there. So I'm going to start off going f prime of x is first derivative of the second. So put what you have on bottom, the derivative of what you have on top, plus the second times the derivative of the first, so times e to the 2x. Now I gotta take the derivative of the top, so times 2. Okay. We don't care about cleaning up the derivative at all. All we care about is plugging in that 0 and getting an answer. So f prime of 0, because that's our x value, is e to the 0 times 4 over 2 plus ln of 2 times e to the 0 times 2. All right, so that's 1 times 2 plus the ln of 2 times 1 times 2. So we get maybe 2 plus 2 ln 2. All right, that's a crappy slope, but you know what? We really don't care, okay? So we get y minus y1, so y minus ln 2 equals our slope, which is 2 plus 2 ln 2 times x minus 0. Again, not the simplest it could be, but who cares? All right. Now, there's the tangent line part of today. Now, the other thing that we are doing today is implicit differentiation, okay? And if you remember, that implicit differentiation thing is the thing where we had to put a dy dx after we took the derivative of something with a y in it. Okay, so let's look at that. Okay, so just doing it without the e's and ln's. So our first step was to take a derivative. Now, this first one is a product rule. So first, derivative of second, plus second, derivative of the first. Okay, plus, all right, the derivative of 2x is 2, equals, the derivative of 3y is 3 dy dx. Derivative of 1 is 0. Okay, so you start by taking a derivative. So now what you're going to do is you are going to get everything with a dy dx to the left side, and then everything without a dy dx to the right side. Okay? So this 2x dy dx is going to stay. I'm going to bring over a negative 3 dy dx. And that's going to equal, I'm going to subtract over the 2y and subtract over the 2. Okay. Now I'm going to factor out a dy dx. And finally, you're going to divide both sides by 2x minus 3 to get dy dx by itself. So we have dy dx equals negative 2y minus 2 over 2x minus 3. There we have it. Okay? So with implicit differentiation, you've got to take a derivative, then simplify and get all the dy dx's on one side, factor out a dy dx, and then divide the leftover stuff. So let's look at that with e and ln. Okay. Now, sorry, hold on. All right, so for this first one, if I want to take the derivative, I'm going to have a product rule there too. So fun. Okay. So if I want to do that, I'm going to take the derivative. So just the derivative of x is 1 plus first derivative of the second plus second derivative of the first. The derivative of y is just dy dx equals derivative of 2, which is 0. Okay? So again, I'm going to keep anything with the dy dx on the left side. So ln of x times dy dx is going to stay. But I'm going to subtract over the 1 and the y over x. I got y over x just by multiplying these two things together. Okay? This time there's only one dy dx, so we don't really even have to factor anything out. All we have to do is divide by that ln x, and we're there. So dy dx equals -1 minus y over x all over the natural log of x. Okay? So again, we took a derivative. We had a product rule in there. Okay, but we took a derivative. We got everything with the dy dx on the left side, everything else on the right side. And then we just had to divide by that ln x. Okay? So let's look at it with ease. All right, so on this problem, it looks very similar to the last one. So the derivative of y is dy dx. Whoa, that was rough. That's better. Minus e to the xy times, okay. Now, there's going to be a product rule whenever I do the derivative of the top. So first, derivative of the second, plus second, derivative of the first, equals 0, because the derivative of 5 is 0. Okay, now I'm going to go ahead and distribute this e to the xy so that I can get that dy dx out of there. So dy dx equals negative e to the xy times x dy dx plus, minus e to the xy y equals 0. And again, I had to do that because I had to get that dy dx out of those parentheses to be able to touch it. Okay? Why did I put dy dx equals? Probably because I'm dumb. Okay. So now I'm going to keep anything with the dy dx on my left side. Again, I don't know why I'm being dumb, but you know me. Okay, keep all this crap on this side. Send the other stuff to the other side. All right, and finally factor out the dy dx and divide everything over. Okay, that 1 came from what would be left over when I factored that part out. Okay? All right, there's implicit. Now the last thing is combining those two and doing implicit with the tangent line. So fun. Here we go. All right. So if I want to do this, I'm going to first find the derivative. So 2y plus, okay, oop, why am I being stupid? What's the first thing we should always do whenever we are about to take the derivative of an ln? We should split it up. So let's just leave this regular whole y squared for now. So y squared plus the ln of x plus the ln of y equals 2. All right, now I get to take my derivative. So 2y plus 1 over x plus 1 over y dy dx equals 0. All right. So again, I'm going to get rid of everything without a dy dx, keep everything with it. Okay, and then finally solve for dy dx. Normally we divide something over, but this time we can just multiply both sides by y. So it's negative 2y minus 1 over x all times y. All right. So now I'm going to use my x and my y, okay, and I'm going to use those things to solve for dy dx and get a slope. So dy dx equals negative 2 times 1 minus 1 over e all times 1. So that's negative 2 minus 1 over e. Again, crappy slope, but we don't care. So our final answer is y minus y1. So y minus 1 equals negative 2 minus 1 over e times x minus e. And there's our tangent line. Okay, so today we went over how to find the equation of a tangent line just regularly. Okay. Then we went over implicit differentiation and how to find the tangent line when you implicit